Hi everybody, and welcome back to our unit on medical geography. We've moved on to part 3. Remember to contact me if you've got any questions about any of the information that we're going over. And of course, you can always check Wikipedia and Google if you think that'll be faster and more efficient. One of the things that we did earlier on was we had this list of questions that I said we might normally talk about with our neighbors, but we can't do that with our online venue. So let's see about how we want to define a disease. So we know that a disease is some type of abnormal condition that's caused by either external or internal factors that has some kind of a negative effect on us. We can take diseases and we can put it into 4 different types as we see listed here. Now, not all 4 of these types will impact different ecosystems the same way, so we are not going to see it exactly the same within a plant community or an animal community or a human community. We're going to focus mostly on infectious diseases. The deficiency, the hereditary, and the physiological tend to be more human, but I'm not an epidemiologist, so don't quote me directly on that. But we're going to look at the infectious diseases because those are the ones that we're probably a little bit more familiar with. So with infectious diseases, one of the things we want to consider is whether or not it is a contagious disease. So is it contagious or non-contagious? So we're looking at how it is transmitted. And as we're looking at transmission, one of the things that we want to pay attention to is what's happening out in the natural environment and whether or not something that occurs in the natural environment disease-wise can cross those boundaries between plants and animals to people and vice versa. So we want to look at those associations. And so that's why I felt it's important for both our conservation class as well as our human geography class to have this joint unit on medical geography. All right, so we've got contagious diseases that can occur in various ecosystems, plants, people, and animals, right? When we're looking at diseases, we want to think about the core area. So where is the hot spot? Where did it evolve? Why did it evolve there? And then how does it diffuse outward from that location? What kind of route is it that spreads the disease? And there's lots of different routes that diseases can take. And we also want to pay attention to where those outbreaks spread to and whether or not they remain in a regional cluster or groups of regional clusters. So if you think back to one of our earlier slides on chronic wasting disease, it wasn't just one place, it was several different regions. And so we want to look at why do we have it in those regions? Are they more alike or more dissimilar in regards to trying to get a handle on the disease and how it spreads and how it impacts populations? So some terms we need to be familiar with. One of those terms is an agent. So that's the disease-causing or carrying organism. We want to think about who the host for that agent might be, whether it's people or other species. And then we want to think about how many people within a population have that disease. The number of people with the disease or the number of animals with the disease is referred to as the reservoir. So contagious diseases can occur through direct contact. If they occur through direct contact, we refer to them as being a non-vector disease. So if we have direct contact with bodily fluids, with food, with fecal matter, with something, droplets, for example, in the air, that's contagious. We can refer to that as something as non-vectored. If it's a non-contagious disease, we talk about it as a vector disease. It's still an infectious disease, but it's non-contagious because it comes to us from another organism. So example, if you get Lyme disease, it's a non-contagious disease, it's infectious, but you get it from the tick because the tick carries the pathogen, and when the tick embeds itself into you, it passes along that disease to you. All right, so the tick becomes the vector. So as we look at some examples for non-vectored versus vectored, non-vectored diseases, contagious diseases, as we see here at the top of the screen listed for us, cholera, influenza, AIDS, All right, contaminated water, pandemics, life cycles, all those things that you can read by yourself on the screen. Those are contagious diseases. They're non-vectored, so direct contact. If we're talking about a vector disease, so it's non-contagious, we don't have direct contact with it, examples would be malaria, yellow fever, sleeping sickness, and Lyme disease, as I mentioned just a few moments ago. So let's look at maps and think about the connection between people and the environment. So this is a map showing us suspected cholera cases in Yemen. Yemen is a country on the Saudi Arabian Peninsula. Cholera is what kind of disease? Is it vectored or non-vectored? Contagious or non-contagious? You might have to go back and check that. But you can see what the outbreak looks like. So we're talking about contaminated water. So where is that contaminated water? How is the water becoming contaminated? How is that water diffusing through space? Meaning has access to the water and how are they using the water? So what kind of sanitary conditions do we have? Yemen has been suffering from a civil war. When we have civil wars, it means that a lot of our infrastructure breaks down, which makes us more susceptible to diseases like cholera. This is a map that shows us malaria. This is confirmed cases per 1,000 people in 2013. The numbers here are in millions. So the Western Mediterranean had 3.9 million cases. Africa had 188 million cases. So you can see what we've got going on in this map. Now I want you to pay particular attention to where we do and don't have malaria outbreaks, right? Where are those locations? What regions do we not have malarial outbreaks based on this map here? Because I want you to be thinking about the environmental conditions. Remember, this is a vectored disease. The bacteria is carried by the mosquito. So you have to be bitten by a mosquito that's infected with it, and then it gets into your bloodstream. So where are mosquitoes? Why do we have mosquitoes in those particular places? What's the environmental connection? So here's a map that's showing us the year 2080. And if you take a look at the map and you look at the key at the bottom, it tells us the number of months that malaria could be present in locations around the world if we make no effort to reduce our greenhouse gas emissions. In other words, we're talking about climate change. And so what kind of impact does climate change have on our physical environment? And as a result, what kind of impact is that going to have on our community health? Because if we are able to have mosquitoes be around 12 months out of the year versus 1 month out of the year because it's warmer, it means that we have a greater possibility for a breeding population. If we have a higher breeding population, that means it's more likely that we're going to get a mosquito bite from a mosquito that has malaria, which means that we're going to get malaria. And we could have malaria more than one time during the course of a year because it never goes away. And as you can tell from the map, the area is going to expand. So we do have connections between our environmental conditions and our social conditions. And if you want to learn more about this one in particular, I put the web page at the bottom of the slide. We can also look a little bit at chronic and genetic examples, even though our focus is going to be more on infectious. We can think about heart disease, cancer, etc., the items that are listed here on the screen. But we also want to think about the impact on specific populations. So earlier we talked about impact on populations by ethnicity and gender. This one is about being lactose intolerant. Some of you probably are lactose intolerant. I'm not. I love milk. I drink a lot of it every single day. So I obviously still have the enzyme that's needed to process milk sugars. Some of you don't. So why are some populations more lactose intolerant than other populations? Is it a matter of ethnicity? Is it a matter of genetics? Is it a matter of both? Is it environmental? We want to be thinking about what those connections are and what kind of distribution patterns we have on the landscape as we map a disease. So we're ending here for part 3. Go back and review as you need to review. When you're ready, continue on to part 4.